Okay, welcome to the second example of PROC LIFETEST. At first, we look at this data set. It has this structure. So we're going to read in this data set first. We define two variables. One is check, the other is m. And so this drop statement says we drop these two variables after we construct the data set. But we retain two variables called therapy and cell. Okay. And these start in file cards. We start reading the data set. We put a column variable which counts the number of columns, and we define a check variable which is just a character with one letter, and we get all the labels for the variables, and we assign initiate m equal to column, and then we start reading the first letter check, and during these loops, if m exceeds the column, the final number, the largest common number, then we reset it as 1. So if check equal to s or check equal to t, so that means either it's the standard, or when you start another one, is t, then we ready in therapy and cell. Okay, and after that we're ready in the 5 variables, numerical values, and then we, if survival time is not missing, then we dichotomize it into censored variable. It's less than 0, so it's negative, it's censored, and then we get the absolute value for the survival time and the treatment, and then we read in all this data set. Okay. So this is the way, so it's a fairly complicated data structure. So we read the mean here. So the purpose of these, okay, let's take a look at the data set we're reading in. Okay, so this is the data set nicely constructed based on the previous data step. So in this example, we're trying to demonstrate how to use PROC LIFETEST to produce a product limit estimate of the survival function for each type of cancer cell. Okay, we already know how to do that from exercise 1, so we use the strata statement. And we want to analyze, this is something new, the effect of covariates like age, prior, diag time, key pace, treatment on the survival time by using test. The third one is we're using the ODS graphics, which is somewhat new to SAS. We can produce the graphs of the product limit estimates. There's a couple of them. If you use plots equal option, you can use S for survival functions, log survival function, the log estimate, so LS, or the log of the negative log using the LS option there. Okay, and the log, negative log, this is very useful for eventually the model assessment, like the proportional odds option in Cox regression. So okay, so here let's see ODS graphics on, and then PROC LIFETEST data equal to VA log. So this is how we specify. We request 3 types of plots, and we output the data set equal to a data set called a test that will give all the chi-square statistics for associations. Maximum time 600, and we want to specify the survival time versus censoring. 1 is censored here. Okay, and ID therapy, this is tells the PROC LIFETEST which variable we're kind of labeling the survival curves. And strata, that's the cell type, and then we test. You just put the list of the variables you want to test there, and then you close off ODS graphics. Okay. So here, this is the results. Okay, so life test, we get 1, 2, 3, 4 stratum. You get, for each stratum, you get the product estimate and summary of survival time, things like that. And then you get a sensor summary for each subtype. And you get strata homogeneity. You get a log rank test and Wilcoxon test. Seems there's heterogeneity. The stratas are different. The survival times are very different in the subgroups. And then you have the plot. This is the plot for the 4 groups, and you have the this is negative log of survival function over time, survival time. Okay, and then this is a log, so of the survival time over the log function. So you can see this is seems the 4 groups are similar. But the log survival time, there seems the probabilities are very different. Okay, so and we can do you know, the model selection, because we have we're testing different different associations of the survival time versus covariates poured over strata. So like age, prior, and diagnosed time, and Karnofsky index, and treatment indicator. It seems that the Karnofsky index was highly significant. So we kind of want to run a stepwise model building based on the chi-square statistics, and maybe testing all the associations. So what we can do is we can borrow PROC reg, which has a function to do all possible subgroup covariates for the log rank test. So because in here we use the out test equal to test, we actually have this data set called test. So we can create a new data set called R square and just rename the type equal to COV if type equal to log rank. Okay, so we can run that, and now we can take a look at this data set. So this is the data set we created here. And then we can run PROC reg and seems that there are some issues with the code here. This is probably because this may be for SAS 9.3, and I only have SAS 9.2 here. But we do have some results from the PROC reg run. So we get the mean effects, and we get the treatment, the two-way interactions and three-way interactions, and four-way interactions, and eventually all the five-way interaction. You get a saturated model here. Okay, but you can see after you put in the KPS, then the subsequent addition doesn't really increase the R square a lot. Okay, including the adding the interaction terms. Okay, so this tells us something. The KPS, the index, really stands out as a significant predictor for the survival time.